Alright guys, I'm going to do example 3 from the notes today. So example 3 says carbon dioxide is a greenhouse gas that is emitted into the atmosphere from a variety of artificial and natural sources, including automobiles. The table below shows the concentration of carbon dioxide, CO2, in the atmosphere, measured in parts per million. When you're entering your data, you need to use x equals 0 to represent 1970. So what that means is for our x values, we're not going to put these dates in. We want to represent it as years since 1970. So 1976 is 6 years after 1970. So our x value there is 6. 1978 is 8 years after 1970, and so on. So I've gone ahead and I've changed these to be the years since 1970. And our y value is the CO2 in parts per million. So we're going to take our calculator. You're going to press Stat and Enter for Edit. And you're going to put your X values into list 1 and your Y values into list 2. And then go back and double check that they match, that 6 goes with 332 and 8 goes with 335. Because these are coordinate points, we need to make sure they match up side by side here. So we're going to find the line of best fit. Once you have all of your data put into your calculator, we're going to press Stat, Calc, and we're going to select number 4 because that's our, it says Lin Reg AX plus B. I put my data into list 1 and list 2. So I'm going to enter through these, and now it's going to give me this information. It reminds you which formula we're using right up here at the top, and then it tells you A and B. So you're going to take A and plug it in for the A spot, and B, plug it in for the B spot. So we're going to have here y equals 1.49, we're just taking A and plugging it in, x, and B is a positive number, so we're just going to round that to a whole number, 323. So that comes straight out of our calculator. We did Stat, Calc 4, so the Stat button, arrow over to the Calc button, and then choose number 4 for our regression. And we just plugged in the information. So we want to interpret the meaning of the slope and the y-intercept in the context of this problem. Alright, so our slope. So slope is when x changes by 1 unit, what happens to y? So when we look at x, the units it's in is in years. So for each additional year, so each year, what's happening to the y values? Well, they're changing. This is my slope. It's a positive number, so that means the CO2 increases because it's a positive number, and average 1.49 parts per million. Okay, so for each additional year, the CO2 increases an average of 1.49 parts per million. It's in the context of what x and y actually are up here in the problem, and it describes slope. Every time x increases by 1 unit, what happens to y? Okay, slope. Y-intercept is the other one we want to talk about. Y-intercept occurs where x is 0. So when x is 0 is in 1970. So in 1970, the estimated CO2 level was, well, when I look, here's my y-intercept, 323. So 323 parts per million, because that's how it was measured. And that's how you're going to interpret your slope and your y-intercept. Slope, each time x goes up by 1 unit, what happens to y? And the y-intercept is when x is 0. So in this case, it says x is 0 is 1970. What was the y value at that time? Okay. So other questions that you might be asked is using your calculator to find the correlation coefficient. We've actually already done that. When we go back into our list, when we did the Stat Calc 4, correlation, remember, is the variable r. So here's my correlation coefficient right down here. So I've got r equals 0.9985. And what does that mean? Well, in class today we talked about 0.99. Well, that's strong. It's a positive number. And we're going to go with that it is linear, or we wouldn't be doing regression on it. Strong positive linear relationship. Between our x and y. Between years since 1970 and the CO2 level. Okay? So your interpretation, tell me what this number means. It's strong, positive, linear, and it's a relationship between x and y. Well, x is the years since 1970, and y is the CO2 level. Our final question in example 3 is using the line of best fit, estimate the number of parts per million in the atmosphere in 2008. So I'm giving you a year. When I look back up here, years are my x values, so that means plug this in for x. But remember, it says years since 1970, so if I'm not sure, let's go ahead and quit. And I want to know 2008, how far away from 1970 is it? It is 38 years. So it means I'm going to plug 38 in for x. I'm going to take my equation. Y equals 1.49x, I want to know about 38 years later, plus 323. So I can just plug this in, 1.49 parentheses 38, close them, plus 323 equals 379.62. And we're talking about the CO2 level, so we're going to add parts per million here. I could have asked, well, if the parts per million is this, what would the year be? And then you'd plug in for y instead of x. You've got to ask yourself, which value, which variable is the question asking? Is it for x or is it for y? So I'm going to do example number 4 in another video. Make sure you guys go through these. Stop them as you need to, and hopefully this will be helpful. See you tomorrow.